Okay, in this video we are going to look at evaluating 5 other trig functions. So we're given one trig function, right? In this first example, all I'm given is the fact that cosine is this. And then I'm also given information which quadrant the angle is in. So therefore, we need to evaluate the remaining trig functions, all 5 remaining trig functions. Okay. In the second one, we have tangent, and again, some restriction. It's written differently in which the angle lies. Okay. All right. I'm going to take 2 approaches. In the first one, I am going to use formulas. Okay, we have sine squared plus cosine squared of some angle equals 1. No matter the angle, sine squared of that angle plus cosine squared of that angle is 1. So let's start with that. I'm going to go ahead and write that. Plus cosine squared equals 1 of any angle. That's a squared up there. All right, that's a Pythagorean identity because it comes directly from the Pythagorean theorem. Why that's true is a topic for another video. The second thing I want to point out is, so here we have x and y, and there's an acronym, all students take calculus. And what that acronym represents is the trig functions that are positive in the corresponding quadrant. Okay, so all trig functions are positive in quadrant 1. Only sine, well, and it's reciprocal, so cosecant as well, is positive in quadrant 2, tangent quadrant 3, cosine quadrant 4. Okay, so the easy way to remember that is all students take calculus. Really quick, let's justify why that's true. Remember that on the unit circle, sine corresponds to the y value, and in quadrant 2, all coordinates, right, all points are negative x, positive y. So since the y is positive, sine is positive. Tangent in quadrant 3, both x and y are negative, and since tangent is y over x, right, negative over negative is a positive. And then cosine in quadrant 4 because it corresponds to the x value and the x is positive, right? So a couple background quick refreshers before we move forward with this. Now, when I do this first example, you can do it in the method I'm going to do in the second example and vice versa. I'm just choosing to do one of each to help you get going. All right, so sine squared t, since that's the angle they're using here, plus cosine squared, so 1/7 squared, I know will be equivalent to 1. That's true for any given angle. So therefore, 1 over 49 equals 1 sine squared. Okay, subtract the 1 over 49, so 1 is 49 over 49, right? So subtract 1, we get 48 over 49. Sine squared. And just like solving for x squared, we can take the square root. Now remember, when you do square root, you get a plus minus, okay, always. We could have actually even started with, get one more color in here, orange is fine. Knowing whether each of these are positive or negative, like if I'm in quadrant 4, I know sine of t is going to be negative from the get-go, right? So either make that note right when you begin, or remember when you do a square root, it's plus or minus, and in this case I'm in quadrant 4, I want the negative, all right? So square root of 49 I know is 7. We need to reduce 48 if it does. We could do, 4 and 12, 2 and 2. Here's how I do square roots. If you do it differently, that's fine. So I have a pair of 2's and another pair of 2's and then a 3. So therefore, the square root of 48 is equivalent to 2 times 2, which is 4 root 3. Okay, and again, it's negative. So now I have sine and cosine. Tangent, there's an identity that says tangent. I guess I should write that up here as well. That is sine over cosine. Oops. Sine over cosine. So tangent of t is negative 4 root 3 over 7 over 1/7. And the easy way to simplify when we have denominators that are the same, we could simply cancel them out like that. And negative 4 root 3 over 1 is just negative 4 root 3. All right, now we have sine. We had cosine because that was given. Right, that was the one that was already given to us. Now we have tangent. So this is negative 4 root 3. Sine of t was negative 4 root 3 over 7. And the remaining 3 are quite easy. They might need a little bit of simplifying. But remember, the s sine goes with the c cosecant. And when I say goes with, I just mean it corresponds. It's a reciprocal. So cosecant, instead of negative 4 root 3 over 7, we flip that, right? The reciprocal, cosecant of t, is 7 over negative 4 root 3. And we need to rationalize, so multiply by root 3 over root 3. So we get 7 root 3 over negative 4 times 3, root 3 times root 3 is 3. So over negative 12, I'll just move the negative out front there. So negative 7 root 3 over 12. All right, secant, right, the s and the c are reciprocals of each other. So not sine and cosine, but cosecant and secant. 7 over 1 is just 7. And then we have cotangent. That one, I mean, that one's kind of easy to remember which is the reciprocal because tangent, cotangent. Okay. Well, we have negative 4 root 3, and if I do the reciprocal of that, so my last scratch work here is 1 over negative 4 root 3, but again, we'll have to rationalize, so multiply by root 3, and cotangent of t is root 3, we'll just move the negative to the numerator, and then negative 4 times 3 is 12. So negative root 3 over 12. All right, so now we have all 6 trig functions. Of course, cosine was the question that was given to us. And just to verify, we're in quadrant 4. Everything should be negative except cosine, and we're good. And of course, it's reciprocal, so secant should also be positive. Everything else is negative, which we have. Awesome. That is one approach. Okay, that method works great. Nothing wrong with that. But let's look at it a different way. And I chose to do the first one that way because I remember sine squared plus cosine squared equals 1, but I don't remember off the top of my head the tangent one. Okay, now we can derive it. It's not difficult. Since tangent is sine over cosine, if I took each of these here and I divided by cosine squared, I can get the other one, right? So what do I mean by that? So I'd have sine squared over cosine squared is tangent squared, and then cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So now I have the other formula to work with, right? I could get secant first, plug in 12 over 5 into this tangent squared formula. But I don't like that. I like sine, cosine, tangent. Nothing wrong with that way. It's just preference. So let's do this instead. Just like that one, I need sine, cosine. We have tangent, right? But I'm just going to write them all. It's kind of a habit. If I'm doing all 6, I just write them all. So I have this one, 12 over 5. Okay, and then we need cosecant, secant, and cotangent. Right. Well, might as well knock cotangent out of the way. That one's just a reciprocal. Done. All right. And then I'm going to look. It tells me theta is between pi and 3 pi over 2. Remember that pi is 180 degrees, 3 pi over 2 is here. So therefore, I'm somewhere in here, which means I'm in quadrant 3. And if I'm in quadrant 3, only tangent and cotangent are positive. Okay, the rest I know are negative. It's a good habit to almost think of that first. That way you don't forget it. Okay, now I stole this problem from the book, but they had theta and they actually use a t, it doesn't matter. Between 0 and pi over 2, they put us in quadrant 1. That was kind of boring because they're all positive, so I changed that problem just slightly. All right, moving on. Tangent is 12 over 5, but I also know tangent in a right triangle, right? SOHCAHTOA is opposite over adjacent. So if I drew some angle theta, I don't know what it is, that's why I just draw a random triangle. It's not even to scale because, right, opposite is 12, adjacent is 5. That's not even drawn well, right? That's opposite and adjacent. But I could get the hypotenuse from Pythagorean theorem. So this is my C, or my H, right? Adjacent squared is 5 squared plus 12 squared, opposite squared, equals hypotenuse squared. We'll go ahead and do H. Okay, we don't need a C. So that's 25 plus 144 equals H squared, 169. I know this one because it comes up enough, but H has to be 13. And notice I didn't mess with the negatives, right? I know I'm in quadrant 3. I know sine, cosine, everything is negative but tangent. So therefore, I mean, we could have went ahead and like, first off, hypotenuse is always positive, right? So I could have made this negative and negative, but it wouldn't have changed the end result. Because negative 5 squared is 25, negative 12 squared is 144. So let's let that be. Now, if this is theta, I can do the trig functions using SOHCAHTOA. Sine is opposite, so here's my opposite, right? Over hypotenuse, 12 over 13. Negative because we're in quadrant 3. Adjacent over hypotenuse is 5 over 13. Again, negative quadrant 3. Now cosecant and secant, I just do the reciprocals of sine and cosine respectively. So cosecant is negative 13 over 12. Cosine is negative 13 over 5. All right, this video, once again, it brings in this whole, how all these are interrelated, right? We had Pythagorean theorem, we had these special triangles, we have a unit circle, we have right triangles, and even though they're taught distinct from each other, they really are all interrelated, and we want the techniques and the tricks from each section to come into play. And that's why the very beginning of trig is often the hardest, just getting used to maneuvering around the trig functions with all these tools that you're equipped with.